Hello everybody and welcome to our video today as we talk about General Chemistry, Chapter 2, Periodic Table. Alright, so again, this video is going to be very short and sweet, not too much detail to cover, okay? This again is just some really important foundational things that we'll build on in our next couple of videos, alright? So let's get into it. So we have a very rough example draft of our periodic table. Just to show you the different components of it. So we have our alkali metals, okay, alkaline earth metals, transition metals, the metalloids, okay, that are along this staircase here. We have our non-metals, we have our halogens, and then the noble gases, and then the rare earth metals. Again, pretty simple, common, general chemistry, things that you've probably learned before you're studying for the MCAT. I hope you've covered at least some of these things in a little bit of detail in some classes. It would be kind of important to know some properties of metals and non-metals, but other than that, I'm not really going to get into it. But what is kind of important for us in this chapter are the periodic table trends, okay? And so we're going to go over that right now. We have atomic size, okay? And atomic size increases as you go down the periodic table and increases to the left. So this means that, for example, if we have sodium, all right, let's use sodium and potassium as an example, right? Ooh. So we have sodium up here. And if we look at our trend, it says atomic size increases as you go down. And this is because the elements, as you go down at each row, right? At each row, they increase a shell, right? They increase an energy level, okay? So you can see that if you go down, you're increasing just the atomic radius in general, all right? So as you go down, the atomic size increases because those elements have more energy levels. Okay, and we are going to say this atomic radius or the atomic size increases to the left because as you move to the right, you are adding electrons to the outermost shell, but this means that the inside, okay, where it has the protons, it is pulling the electrons even more tightly inside as you're moving this way, okay? So if you're having a nucleus that's pulling these electrons in more, the radius is going to be, the atomic radius and the atomic size is going to be smaller, okay? So that's why the atomic size increases as you go this way, okay? Because as you move to the right, you are getting smaller and smaller because those electrons are being pulled in even more, okay? Because you're adding more electrons to that outermost shell that are interacting with the protons in the nucleus that are really pulling that even tighter inside, okay? Or towards its center, I should say. All right, so electronegativity is another super important trend. Okay, that deals with the polarity of certain things, or the difference in electronegativity, dictates the atoms or molecules' polarity oftentimes, right? So electronegativity is super important. And the electronegativity trend increases as you go up and increases to the right. So that means fluorine, okay, which is right about here, is the most electronegative atom. Okay, so that's an important thing to remember. Then we have the electron affinity, which is the element's ability to gain an electron. So except for our noble gases, this is also going to increase to the right. Okay, all of these trends increase as you move to the right, except for atomic radius, okay, which was the first one we discussed. So all these other trends that I'm discussing now are all going to increase as you move to the right, okay? So yes, the electron affinity is the ability to gain an electron. And, we can see that, for example, if you're comparing sodium to fluorine, right? Because fluorine has almost a full octet, it is very easy for fluorine to just gain one electron to become stable compared to sodium, right, who only has one valence electron to begin with. So for it to gain an electron would be a lot harder, right? Which is why the electron affinity, the ability of an element to gain an electron, increases as you move to the right, because you're getting closer and closer to this stable form, based on the valence number of electrons, okay? Next we have ionization energy, which is the energy required to take away an electron, okay? And this again increases as you move up and increases to the right. And if we use our sodium and fluorine example again, right, fluorine really wants to hold on to those 7 valence electrons that it has, right? So the energy that it would take to take away one of fluorine's atoms is much bigger compared to sodium. If you were to take away one of its valence electrons, right, that would be much easier to take that away from sodium compared to fluorine, right? Because sodium only has 1 valence electron. If you take it away, great. It loses a energy level, but sodium will be stable. Compared to fluorine, it has 7, so it really, is hard to take away those electrons. All right, so sorry, when I say 7, I mean it has 7 valence electrons. So our last trend is our effective nuclear charge, and this is the pull between the nucleus and the electron, and again, it increases to the right. That one I have not necessarily seen as much, I have not used as much. It's still important to know, but yes, anything that I've personally looked at or studied has been more so with the electronegativity, ionization energy, but the effective nuclear charge is still, important to know. So it's the pull between the nucleus and the electron, and that also increases as you move to the right. And as we said, that is why the atomic size actually decreases when you are moving to the right, because the pull between the nucleus and the electrons is much stronger, okay, as you move to the right. So I hope this video clarified those trends for you. Like I said, just know some of the, just the basic properties of metals, non-metals, but hopefully, we've been over those things before. So I hope you enjoyed this video. If you have any other questions, comments, concerns, please leave them below. And if not, I will see you in the next chapter.